Hello everyone. Hope you are doing good. So today we'll be starting with the part second of question number 4 from the exercise 8.3 of grade 10th NCERT textbook. So let's start. In this question we need to prove that cos A over 1 plus sin A plus 1 plus sin A over cos A equals to 2 secant A. In the right hand side there is 2 secant A. We can't solve it much because 2 secant A is just 2 over cos A, right? So that's why starting with the left hand side to prove the results. So how to start? Your left hand side is cos A over 1 plus sin A plus 1 plus sin A over cos A. As we discussed in the previous question, to make the question easier, what we can do is convert your whatever is there on your on the side you are solving in simple cos and sine, but it's already there in sine and cos terms. So what to do? Consider it like two fractions. How do we add two fractions? This is the first fraction, this is the second fraction. How do we add two fractions? By taking the LCM. And what's the LCM in case of two fractions? Take this example 1 by 2 plus maybe 3 by 7. If the denominators are different, how do we take the LCM? When there is no common factor in the denominator, how do we take the LCM? We simply take the product. Similar way, since there is no common factor in 1 plus sin A and cos A, which is there in the denominators, that's why the LCM is the product of both the denominators, that is cos A times 1 plus sin A. Clear? Now, the next step is how do we get the term over here? Divide your LCM with the first denominator. So when you divide cos A times 1 plus sin A with 1 plus sin A, like this is your LCM. Dividing it with the first denominator, which is 1 plus sin A. What we are left with is just cos A, right? Now that cos A times the numerator. Cos A times cos A is cos square A, right? Similar way, dividing your LCM to get the term over here, dividing your LCM with this denominator. So when you divide cos A times 1 plus sin A with cos A, what we are left with is 1 plus sin A. Now this 1 plus sin A times the numerator is 1 plus sin A whole square, right? Moving forward, what to do next? See, we can clearly see denominator can't be solved further. So writing the denominator as it is, cos A times 1 plus sin A. In the numerator, you can clearly see a plus b whole square, right? So using the identity a plus b whole square in the numerator, using a plus b whole square, that is equal to a square plus b square plus 2ab in the numerator. Where your a is 1 and b is sin A. What we are left with is cos square A at its place plus a plus b whole square. A square means 1 square, b square means sin A whole square, that is equivalent to sin square A, plus 2 times ab, which is 2 times 1 times sin A, that is 2 sin A, right? Which can be written as cos square A plus 1 plus sin square A plus 2 sin A over cos A times 1 plus sin A. Now, we know that cos square A plus sin square A is 1, right? So, using that identity in the numerator, using cos square A plus sin square A equals to 1 in the numerator, we have cos square A plus sin square A is 1. So, writing 1 in its place plus 1 and plus 2 sin, right? Divided by cos A into 1 plus sin A. which is equal to 1 plus 1 is a 2. So 2 plus 2 sine A into cos A. Taking 2 common in the numerator, we are left with 1 plus sine A divided by cos A into 1 plus sine A. So this 1 plus sine A and this 1 plus sine A gets cancelled. We are left with 2 over cos A, or we can write it down as 2 times 1 by cos A, and we know that 1 over cos A is secant A, which is your right hand side. See? So our left hand side equals to the right hand side, and hence proved, right? If there is anything you are not getting, you can ask in the comment section, or you can message me on my Instagram channel. I'll be mentioning the link to the channel also in the in the description box of this video. Yeah, so that's all. For more such videos, do subscribe the channel and press the like button. Thank you.